You make a strong point. So, there's no further conversation here.
What I'm arguing was the correction column, because honestly, it was tough to deduce the mathematical corrections where they applied. All we have is the measurements. I don't have the reasoning for the corrections that they're applying. So literally, we're retroactively trying to deduce what that was, and that's why I'm asking you what it was. But to me, I'm surmising based on what I've seen and what I've read that they're literally comparing it to this handy dandy lat long system that they already had, and then getting the correction measurements from there. And that way, neatly throughout the whole report, they get 180 down the whole corrected column, right?
No, I don't. The 180 down the whole corrected column. You're looking at must be in the eastern portions where the triangles are small.
Well, where was the corrected column not 180 then?
I don't have it in front of me, and I can't recall specifically.
It's also annoying because they don't actually add them up on the sheet. That's the summary sheet, as you see over here. This is how it's displayed. So if you can quickly gauge all three of these measurements and see in your head if they're 180, you're way smarter than I am, because I couldn't do that. I had to add them up. So it's not visually stirring. But if you go through and add them all up, the corrected column almost always equals 180. And if you could just quickly explain to me why that is, why the measurements are 180. They make measurements like 179 and 99 seconds, and then it ends up being a measurement of 180 or more. How does that happen exactly?
Again, the eastern reaches of that survey, the triangles are small. Vertical excess is hard to observe.
It's almost non-existent, I would say.
I mean, what I would think, and correct me if I'm wrong on this, I'm obviously not an expert, but, thinking about geometry and, let's even put it in 2 dimensions, right? We got the circle, right? Is there any point on that circle that there wouldn't be spherical excess? I mean, the answer would obviously be no, right?
On a sphere, by definition, on a sphere, all triangles on a sphere exceed 180. But when you're particularly small, and you're confronted with actually measuring that on the sphere the size of the Earth, got to be a couple hundred square miles before it becomes.
It's simply I'm going to make this simple. Simply invoking scale does not explain away any observation. You would have to actually demonstrate how this is true, even on a small scale, like on a small piece of paper. I mean, how small would the triangle have to be for it to not have any spherical excess at all?
Well, on paper, it's even extra easy. Yeah, if you're dealing with a triangle that has the sides in the multiple degrees of length.
So, just one totally different point on this. For the measurements that you're making optically through your theodolite, do you take refraction into account? And specifically, did the arc of the parallel take into account refraction? Is refraction a factor in any of their measurements?
So yes, particularly in the zenith angles.
Well, so
in the horizontal angles, there is a minor impact of morning and afternoon, so that's why they made sure to make measurements in morning, noon, and afternoon.
Well, I mean, that's a better answer than most global scale.
Horizontal refraction is a very different impact than vertical angle refraction.
Well, I mean, I'm reading from, like, let's see, page 206, and it says, corrections demanded by the adjustment of the base net measurement of this arcsecond and the same as derived from the Staceman adjustment of another arcsecond. And then it goes into persistent lateral refraction also has a share in producing the above result. And then it goes on to denote the formula that they derived to calculate that refraction. Isn't it odd that we're claiming that the optical measurements we're making above this really tiny threshold are actually persistent above and beyond what we can calculate for, like, refractive indices?
Sorry,
yeah, you're right. No, you make a strong point. So, there's no further conversation here.